2, so that makes sense. And let's go ahead and put 2 in there. What is 1/2 to the second power? It's 1/4. 1/4 times 4? 1. So you see this is coming down like this and growing like that. So if this will stay there, I don't know if it will, I'm going to go change my function. Is 4, and this is 1/2, right? Yeah, let's see if it works. Oh, look at that. I lined right up with what I drew. You see it? Well, maybe I was off a little bit. That's just because I'm artistically challenged anyway. You see I hit the key points here. You see that? And I had it grow exponentially this way and asymptote this way. I probably could have had it grow faster. And if I wanted to be a little bit more precise, I should have probably put -1 in. What would -1 be? 4 to the 1/2 raised to the -1. Well, -1 is going to flip this over and make that 2. 2 times 4 is 8, so at 1 it should have been 8, and had I made that point, then my drawing would have been even better, right? But I was just trying to illustrate the point of how it grows exponentially that way and decays this way. So let me reiterate one more time. The key points will be like -1, 0, and 1, something right around the origin, so that you can relate to what's happening. And always at 0 will be the initial value. Whatever's out in front will always be your y-intercept. Okay? Now there's one here, let's see which one it is. Yeah, we'll go to number 6, I suppose, that's good. Number 6, let me write it on the board. Okay. If you can see this, there is a parent function here, which is 1/2 to the x. Now, to this parent function, we've actually multiplied the front by 2. We've actually done some kind of horizontal translation and some kind of vertical translation, which you remember from doing the same kind of work with the quadratics. Remember, we used to move those parabolas around, or the what's the absolute value symbols around. Now we're going to do the same thing with this. For example, this x plus 1 is going to be a horizontal shift, but which way? To the left or to the right? Right, because, I mean, correct. The left because it was counterintuitive, right? And this plus 1 will take this 1/2 and push everything that way. Now notice this was, I think, 4, right? Was the initial value? Yeah, let me go back to the original one here so we can just play with it. So take that 4 out of here. Okay, this is the original one. Notice it goes now through 0, 1, just like all the original ones should. The parent functions go through 0, 1. That's what makes these the parent functions for the exponential growth and decay model. This will push it over that way by 1, so now instead of 0, 1, it'll be -1, 0, and it'll look just like this. Follow the same pretty much pattern like that. In other words, just push the whole thing that way by 1. Next, we're going to stretch it out by 2. So the initial value becomes 2, so this is going to go up to 2, which means it's going to grow a little bit faster and decay a little bit quicker. And the second thing is we're going to take the whole thing and lift it up in the air by 2 points. So what happens here is this goes up to 4, the 0, 1 goes, let's see if I get this right here. We're going to have an asymptote here too, so it's going to look something like that. Notice that the asymptote was at 0, but I lifted everything up by 2, so now we'll have an asymptote at 2, because the outside vertical thing is going to be the last positive number we can reach. I'm not sure how this works. Let's see. All right, so I'm going to go do it now onto this one and see if I can't get it. So out in front we have what? 2? And then the whole thing is the x plus 1, so that's going to move it over, and then we have a shift, right, of 2, oops, a shift here of 2, I guess. Let's see what that looks like. And that bad. If I take away the original here, minus, well, it's, hey, for me, that's actually really good because my, again, my artistic abilities aren't that good. And all I did was moving things around, and I pretty much nailed it, I'd say, right? Think you guys could do that? Maybe? Why don't we, why don't you take a second to try the number 5. Notice what the minus 2 is going to do to the asymptote. Try not to look at the answer. Just take a second. I'm going to plug it into the calculator, to the software here, but I want you to just play with it. If you get it wrong, it's okay. I just want you to get your hands dirty with one here and see what happens. We have 3 times 2 to the x minus 1 all minus 2. Is that what I saw? Yeah. What I have graphed here is 2 to the x. This is 2 to the x. You can see that parent function is 2 to the x. That's the parent one. Notice that the value of a is bigger than 1. It's in here, so we get our exponential growth as different from the decay we just had. And 2 to the x would go through 1, 0, 1, and again, this is a standard 2 to the x. Now we're going to take this blue graph, and we're going to do this stuff to it. So what did you do first? Pushed it which way by what? To my left or my right? To my right, because again, counterintuitive. Remember, inside the parentheses, everything's counterintuitive. So this minus 1 pushes it to the positive by 1. So now at 1, we'll go through our initial value, and we're somewhere around here, I guess. Probably could use better. Not like that. Again, I'm sort of slacking up here at infinity too, aren't I? Rough estimate here, no big deal. Then what are we going to do with the 3? That's going to change the initial value and stretch everything out to 3. So instead of going through what was 0, 1 here, it's now going to go through 3 here. So take that and say that. And then what's the minus 2 going to do? Take the whole thing down to negative 2. We're going to have our asymptote down here now. So this whole thing is going to drop exactly like it looks. Let's see, from down to 3, if you go down by 2, you'll be at 1, right? So let's see if I can get this right. I'm not feeling this confident about this one, but it should be close, don't you think? Let's see what the other one looks like. Oh, I'm pretty close, right? This is the, well, actually I'm pretty far off over here. I did kind of get the right values here. I did get the asymptote happening here, but I guess it grew a little faster than I had moved it there. Now, I have to be clear to you, I could have done a better job had I actually taken a couple values like minus 2 and 1 and got a picture going on there. I'm just after the general idea here. I'm not trying to make perfect graphs yet. We'll be there soon enough. Just want you to see the behavior that's associated with this thing, that's all. Okay. Now the last part of that worksheet was to actually come up with an equation given a graph. From our work here,